Okay, so this is Project 14, the final project for this class. What follows are some very simple examples of the things that I want you to do for your final project. In the last presentation, Deciphering the 24-Step Color Wheel, I was explaining that we would begin here. This is the full spectrum 24-step color wheel matrix showing all of the hue chroma triangles from color 24 through 1 with a grayscale located at the very end. This shows the position of the 24 pure hues within the matrix. Notice how they jump up and down relative to the grayscale at the end of the matrix? As you know by now, this is due to their value. Now I'm going to give you the most simple definition of the following terms. I want you, with your final, to complete one each of the following examples using your parent image, which will be the first example. Your parent image, translated into the colors of our matrix, is the starting point, represented here by this. This simple 6-color example, which will stand in for a parent image, in your case, you were to take an existing image and reinterpret it using the class-generated 24-step color matrix. Your example may be as many as 16 colors based on the way that you were able to break your original down using the Illustrator program in that demonstration that I showed you on how to do that. This simple example has 6 distinct colors plus a pure black background. I chose 6 to make this demonstration a bit easier to comprehend and to lessen the amount of confusion with the diagrams that I'm going to be showing you here. The position of these colors on the hue chroma matrix is this. Notice that black is at the bottom of the grayscale column and the other 6 colors are located where they would be found along the matrix. The first example that I'm going to ask you to produce is called a color reversal. Again, your example should have as many as 16 different colors, although some of them may simply be different values of the same color or hue. Our example, with the 6 colors shown here when reversed, looks like this. Notice that the black background has become white. Also, every color on the original has reverse position within the matrix. The position of the new colors within the matrix are as follows. Notice that white is now at the very top of the grayscale column and all the other colors have shifted position within the matrix. Here's where they started from, and to make it a bit clearer, here's where they shifted to. The arrows indicate the direction of movement within the matrix. Perhaps now you can understand why I limited the example to 6 colors. Try following 16 arrows. Again, most of them appear to have shifted back down the matrix, but one of them came forward. This is example 1 of what I'm going to ask you to do. Part 1 of the final project is a color reversal study of your parent image. Okay, let's take a break here for a moment, and then we'll tackle the next one, which is the expansion of hue. Again, this is our original example. An expansion of hues would look like this. All of the colors have been pulled up and over to represent their most pastel form. This represents a bottom to top motion within the matrix and is much like the tints example that you did in acrylic. The position of the hues in the expansion within the matrix are located here. Their original positions were here, and again, to make that easier, the arrows show the position shifts. Part 2 of the final project is to do a color expansion study of your parent image. Okay, so now we're ready to move on to the example 3, which is the contraction of hues. This is our simple 6-color example, and when we contract the hues, it will look like this. Here the colors have been moved down through the hue values to the point where they are still able to discern what color they are without going to complete gray or black. The background has also shifted. This time, instead of pure black, it is now represented as a dark gray and can be found on the grayscale without going all the way to black. Here are the position of the 6 hues and the gray background. If you were to look at their position on the original hue chroma triangles, they would be just above where you could no longer discern a color. And here is where the original hues originated from in the matrix. And the arrows help to show you where they went. The perspective is a bit deceptive here. They may look like they are moving forward as well as down, but they are actually simply moving down in one direction. So this is part 3 of what I want you to do for the final project, a color contraction study. Another pause before moving on to part 4, the color shift. This one is a bit more difficult to explain, so I have included several additional slides to help you understand what I mean. We begin with the simple 6-color original, and when we shift the hues, it will look like this. Notice that the black background has remained, but the colors themselves have shifted by 4 positions within the matrix. In this case, 4 is an arbitrary number. You can move 2 or as many as 6, but you are required to at least shift by 2 colors. And all of the colors have to shift together. For instance, if one of the colors was 01, which is a red, and you were moving by 3 positions, that color would now become color number 22. Sound confusing? Then let me explain. Here's the position of the shifted colors. And this is where they started from. In my particular example here, the shift was 4 positions and will affect the conditions that I was explaining just moments ago. In particular, here's the position of the first original color. It is near the back of the matrix. It will move forward by 4 positions. Now I could have elected to move backwards 4 positions, which is also perfectly valid, but once you start, you have to stick to what you began with. So, the second original color was located here, and it moves forward 4 positions and will end up here. So far so good, eh? The third original color was more of a pure hue, and when it moves 4 positions, it moves to red. Now the next 2 moves are the tricky part. The original 5th color ends up only 1 position from one of the shifted colors here. Again, the perspective is deceptive, but this is actually a position high up and quite near the front edge of the matrix. Remember, our matrix is actually a color wheel spread out, and like a torus, it has no beginning and no end, so it continues. And so, the color simply loops around the end up 4 positions from where it was in the matrix. In this case, the first color inside the matrix at the back. The 6th original color is a pure hue at the very front of the matrix, and so it also moves 4 positions forward, ending up 4 positions inside the matrix at the back end. And this shows the shift's colors for the shift of our 4 positions. Again, you can customize the shift however you want. You can move them 2, 3, 4, 5, or 6 positions together forward through the matrix or back. You can also do a custom one where you move 1 color 2, 1 color 3, 1 color 4, and so on. That can get rather difficult. But if you choose to do it, just write out the description or the formula of what you're doing and attach it to the final rendition. So this is the 4th part of the final project, the color shift study. One more pause and we'll take a look at the final study in the series, the hue collapse. So our original 6-color version is here, and what happens with hue collapse. Here's where the colors end up in a hue collapse, and this is their original position. To help you understand how we got here are the arrows to help show what happened. As with the shift study, the position of where you collapse the colors is arbitrary, but once you've chosen the color to collapse into, be consistent. In this case, I wanted the collapse to represent a color that had not been present in the original composition so that the effect would be startling. Here all of the colors had to move position. Only one of them moved forward, the others all shifted backwards. The important thing is that they had to stay as close to where they were in value to the original color. In theory, I stretched this example so as to include all 6 of the original colors, but you will notice that the red not only had to move backwards, but it had to shift over because there was no value in the color that I was collapsing into that corresponded with it. Technically speaking, could have submitted a modified collapse where that color represented by red would simply disappear from the mix in the collapse study, and that would be equally valid. This may be a good thing or a bad thing dependent upon your parent image and whether you might have a significant portion of your composition simply disappear. Then again, that is your choice. So this then is the 5th and final portion of the final project, the hue collapse study. Now you're probably all wondering how I want you to display all of this hard work. I will be handing out this final format frame to you. There is one for a landscape format image if your original parent image was a landscape, and there's also a portrait format for displaying your image if your parent image was originally a portrait format. I haven't yet had a student turn in one that was not either of these, but one of these days someone's going to outsmart me and turn in one that's a circle or some other geometrical format that I haven't had a template for, and I'll have to scramble. Now maybe I shouldn't have said that. Oh well. So here is the suggested landscape format frame. And here's an example of someone's work from a past class. Notice that you see the parent image largest in the upper left corner and the other 5 examples displayed with 2 next to the larger parent image and the other 3 strung out below. I've obscured the name to protect the innocent party who produced this. Here's your example of the portrait format frame. Please note that when you get these frames, they will be in Photoshop and have layers for all the appropriate information: parent image, reversal, expansion, contraction, shift, collapse, and they'll all be on separate text layers. There is also a line for your name and the name of the class and what semester it was for. The windows are actually openings through which you will be able to see your artwork when you install the layer. I want you to insert a TIFF file for each example in the appropriate locations and label them accordingly. Then I want you to output the entire document as a master TIFF file and submit it to Canvas for final. Where complete, I want everyone to share their example with everyone else digitally and printed so that you will have everything that was generated in the class. All of these will join the ranks of the past projects for this class and become part of my next semester's slideshow. Here is an example from the past class showing the portrait format. It is, of course, a movie poster for The Lion King. Note, you do not have to maintain the original black frame. You can see from both examples presented that you can shift to whatever background that you would like. I will insist that you maintain the Arial font for the text and in the locations where they are located on the formats. Now, as a final presentation, I will be showing you quite a few examples that represent a compilation of the best from several years' work from previous classes. This way you can get an idea of what other classes have done. So then, this is what the final will consist of. Good luck, and use your time wisely.